Today we are going to work on maximizing two-dimensional objects, rectangles, circles, things of that nature. And we'll start with a very basic one, a rectangular one. The concept is the same no matter what the shape is. So here's our problem. Against an existing wall, we're to create the largest rectangular area using 100 feet of fencing. So in other words, you want to make like a dog pen or a grazing area for a cow or something like that. So let's get a diagram going. That's the first step in all of these, is create a diagram. So I'm going to have an existing wall. Maybe it's like a garage wall or something. Yeah, a shed wall, whatever. There's an existing wall here. Sometimes that can be a creek, right? You can't cross the creek, so you put a pen up along the creek. So now we are trying to create along an existing wall a rectangular fenced-in area. Okay, so there's our fenced-in area, and we want to maximize this area. Now we have 100 feet of fencing. It's a rectangle. So we know that the widths here are both the same. We don't know what they are, but we know they're the same. So we'll call them x. So at this point I've used up 2x feet of fencing. Let's say x is 10. We've used up 20 feet of fencing, which means we have 80 feet left. Okay, so if it's 20 for x, we've used up 40 feet of fencing, meaning we have 60 left. Well, I've used up x and x. I've used up 2x, so I have 100 minus 2x remaining, which means my area as a function of x, length times width, right? 100 minus 2x times x. Now I like it like that because that tells me everything I need to know about the graph. It tells me I have a 0 at 0. So let's go different color on that one. Alright, so I can put a 0 right here. It also tells me I have a 0 at 50. I know I have a negative quadratic with two linear roots at 0 and 50. So my graph looks like that. Meaning my maximum area, right, this is x and this is a of x. My maximum area occurs up here at the vertex, which we already know. Now the nice thing is we know how to find vertexes of quadratics, which is what makes this example so easy. We know that the vertex, the x-coordinate, is right smack in the middle of the x-intercept, so that has to be at 25. And in order to find the y value, I simply plug it in. I want to find a of 25, so that's 100 minus 50 times 25, or 50. Whoops, 50. It's interesting how they are erasing there. That is 50 times 25, or what is that, 1225? So our maximum area is 1,225 square feet. Okay, square feet. So the largest rectangular area occurs when x is 25, and we get 1,225 square feet. And that's really all there is to it. We're going to do one other example, and it's going to be the same problem, but we're going to have 100 feet of fencing and an existing wall. Right, we'll do the existing wall again. Same problem so far, but this time we have different animals on our farm. Right, we want to do 3 side by side pens. 3 side by side pens. Alright, so again, let's draw our existing wall. Boom. And we'll make this a little cleaner here. 3 side by sides. So let's say we have chickens. Let's make a small one for chickens. And then we got some cows and pigs. So we'll have chickens, cows, and pigs for grazing. We're going to keep them all separate though. Alright, well again, I have 100 feet of fencing, right? So that's normal there, 100 feet of fencing. Nothing changed. They're rectangular, so all of these guys are now x. Right, so if they're each 10, I've used up 40 feet of fencing already. I only have 60 feet left. We don't know what they are though, they're just x. But what have I used up? 1, 2, 3, 4 x's. So my total remaining for that whole length is 100 minus 4x. If you notice, this is still a two-dimensional shape. It is still a quadratic function. Our area will still be length times width, right? The width, if you will, is 100 minus 4x, or the length, whatever you want to call it. And this dimension is x. So again, that tells me everything I need to know. My graph now has zeros again at 0, but now the other zero is at 25. There are two linear roots. It is again a negative quadratic, so the graph looks like this. Okay, this is our y-axis, which represents area, and this is the depth, width, length, whatever you want to call it, of the rectangular pen. Again, because it's quadratic, as this whole video is featuring, the vertex is right smack in the middle. So we're going to plug in. I have 100 minus 50 times 12.5, or 50. I keep writing 500 instead of 50. I'm not sure why. Or 50 times 12.5. So 50 is half of 100, so that's 625, right? 625. Maximum area occurs at 12.5 for an x value, and it gives us 625 square feet. Stay tuned. Shortly we'll be working on three-dimensional objects and finding the maximum volume. Hope you enjoyed the video.